All right, so get ready because we're diving into a world that's really, well, it's going to blow your mind, I think. We're tackling quantum physics today.
Yeah, it's one of those topics that really makes you question everything you thought you knew.
Totally. You know, you sent in this arcade video, Veranderen Quanten unsere Realität, 42 die Antwoord auf fast Alice, and wow, it is a wild ride.
Yeah, it really is.
Like right off the bat, they compare the quantum world to, get this, a whale. But here's the thing, this whale is swimming in the ocean, right?
Okay.
And it's also flying through the Grand Canyon at the same time.
Right. I remember that. It's a pretty crazy image.
It's mind-blowing, and that's exactly what we're talking about here, that clash between, like, our everyday world and the other strangeness of quantum particles.
And that's the thing about the quantum realm.
Yeah.
Those kind of bizarre scenarios, they aren't actually that far-fetched. It's all about embracing the bizarre.
So are you saying, like, a tiny particle can be doing completely different things at the same time until, like, someone notices it?
That's the gist of it, yeah. It's called superposition, and it's one of the most fundamental concepts in quantum physics.
Okay, so say more about that, because the video used this analogy of a book that's completely blank until you open it.
Exactly. Think of it this way. In our big world, right, if you throw a ball, you can pretty much predict where it's going to land. Gravity, velocity, all that.
Makes sense.
But in the quantum world, if you throw a particle, it's almost like it's traveling every single path at the same time. And it keeps doing that until you observe it, then boom, it collapses into one definite state.
Whoa, okay, that's where I gotta say, mind blown. So is this all just theoretical? Or are there actually real-world applications of this quantum weirdness?
Oh, it's very real.
Yep.
And the applications are incredible. Think about sensors, for example. Quantum particles are so sensitive to their surroundings, like crazy sensitive.
Okay.
The video actually talks about how scientists are using them to make these things called quantum gravimeters, and they're so precise they could potentially predict volcanic eruptions.
No way.
By detecting these teeny tiny changes in gravity. And get this, they've already started testing this tech on Mount Etna.
That's wild, having an early warning system like that. Think of how many lives that could save.
Exactly.
Yeah.
And that's just one example. Quantum sensors have the potential to change everything from medical imaging to, like, how our phones navigate.
Okay, so we've got crazy particles doing multiple things at once, and now we've got quantum sensors that can predict volcanic eruptions. But then there's entanglement. Even Einstein called it spooky action at a distance. It's like you've got these two particles and they're linked and they influence each other instantly, even if they're like galaxies apart.
It's one of those baffling concepts in physics. Like,
Yeah.
even physicists are still kind of scratching their heads over it.
So try and explain it. I'm all ears.
Okay, so picture this, right? You've got two entangled photons, and you send one to, say, Munich, and the other one you keep it in Paris.
Okay, I'm with you so far.
Now, imagine you measure the state of the photon in Paris, and you find out it's horizontally polarized.
Right. Two photons, thousands of miles apart. What happens next?
Here's the kicker. The instant you make that measurement in Paris, you know, for a fact that the photon in Munich will be vertically polarized. It's like they communicate instantly, breaking all the rules of space and time.
So they're like two halves of the same coin connected in this invisible way that like defies all logic.
Exactly. It challenges our whole understanding of cause and effect.
Yeah.
And as much as we've observed this phenomenon time and time again, the how remains one of the biggest mysteries in quantum physics.
It's mind-blowing. And this spooky action, this is what's behind the idea of quantum teleportation, right?
You got it.
Are we talking like Star Trek-style beaming here?
Not quite. When we say quantum teleportation, we're talking about instantly transferring quantum information from one point to another. Not teleporting physical matter, but the state of a particle.
So more like sending a secret message using the entanglement between those particles as like a special channel.
Exactly. And this technology, it's still in its early stages, but it has the potential to change how we communicate forever. Imagine a world with completely secure, unhackable networks. That's the promise of quantum teleportation.
Okay, now that's some next-level stuff. But the video also talks about quantum computers. Are they as mind-blowing as they sound?
Oh, they are. But to understand why, we got to talk about how they work. So there was this brilliant physicist, Richard Feynman, and he's the one who first said, hey, we could use quantum mechanics to build computers.
I can just imagine him like having a eureka moment.
Right. And the key here is that these quantum computers, they wouldn't use bits, which can be a 0 or a 1. They'd use qubits.
Qubits. What's a qubit?
A qubit is like a super-powered bit. It can be a 0, a 1, or both at the same time, thanks to that whole superposition thing we were talking about.
It's like they have superpowers.
That's a great way to put it. And that's what makes quantum computers so powerful. They can be exponentially faster than our current computers. Like tackling problems that would take our best computers billions of years to solve, but in like a fraction of the time.
So that's why everyone's talking about a quantum revolution, right?
Exactly. It has the potential to change everything. But, and this is a big but, it's not without its challenges.
What kind of challenges? The video mentioned something about qubits being like really fragile.
That's right. Maintaining their quantum properties is incredibly difficult. Any little disturbance, a tiny vibration, even a slight change in temperature, and they can lose those special properties.
So it's like trying to juggle like a million soap bubbles at once.
Yeah.
Incredibly powerful, but super delicate.
Exactly.
Yeah.
And the more qubits you try to use, the harder it gets.
So we might not be throwing out our laptops just yet, but it sounds like the quest to figure all this out, it's pushing the boundaries of what we thought was possible.
Absolutely. And that's the beauty of science, right?
Yeah.
Even if we never build those large-scale quantum computers, everything we're learning along the way is invaluable.
It's like the video suggested at the end, maybe our struggle to wrap our heads around quantum physics, maybe it's just because we're, well, human. Maybe future generations, they won't find it strange at all.
That's a really interesting thought.
Like, can you imagine kids growing up with instantaneous communication as just a normal part of life? Entanglement wouldn't seem weird at all to them. It'd be like gravity, just a fact of the universe.
It makes you wonder what other impossible things might become possible as we keep exploring.
It really does, doesn't it? It's a universe full of possibilities. You know, it's kind of wild when you think about it, this whole quantum world operating with these rules that just seem, well, they seem to go against everything we experience in our normal lives.
It's like we're trying to understand a language where the grammar keeps changing.
Exactly. I mean, we're so used to this idea of a universe where everything happens for a reason, you know, cause and effect, and then along comes quantum physics, and suddenly we're talking about like probability clouds and particles that are connected across vast distances.
Right, and this isn't just us struggling to grasp it either. Even Einstein, he had a hard time with this. God does not play dice with the universe, he said.
And didn't Niels Bohr fire back with, Einstein, stop telling God what to do?
Exactly. Like, who are we to impose our classical way of thinking onto the quantum realm? It's a different beast altogether.
It's like trying to fit a square peg into a round hole. It just doesn't work. So how do we even begin to reconcile these two realities? The familiar world of, like, apples falling from trees and then this mind-bending quantum world?
That's the million-dollar question, right? And there's no easy answer. But one way to think about it is through the lens of scale. So at the very, very small level, the quantum world, it reigns supreme. But as you zoom out, as you look at larger and larger scales, these quantum effects, they kind of average out. And that's how we get the predictable laws of classical physics that we experience in our everyday lives.
So it's like each individual water molecule in a wave is doing its own quantum thing, but together, all those molecules create this wave that we can easily understand.
Exactly. Or think about the pixels on your screen. Up close, they're just these individual dots, each with its own color and brightness. But from a distance, they blend together to create this seamless image.
That actually makes a lot of sense. But still, it's strange to think that the universe at its most basic level operates on rules that are so different from what we see around us.
That's the beauty of it, right?
Right.
It's a constant reminder that the universe is far stranger and more wondrous than we could ever imagine, and that there's always more to learn.
Speaking of learning, the video emphasized that even if some of the really ambitious stuff, like building those large-scale quantum computers, even if those don't pan out, just the act of trying, of doing the research, it's already pushing the boundaries of what we know.
Absolutely. Every experiment, every new equation we solve, it brings us a step closer to understanding the quantum realm. And who knows what other amazing discoveries are waiting for us along the way.
It's exciting, isn't it? Like that thought the video ended on, maybe future generations won't find any of this strange. Maybe our struggle to grasp it is just a product of our limited perspective, being so ingrained in this classical world.
I love that idea. Imagine kids growing up with teleportation, entanglement, all of that, just being normal, everyday stuff.
Exactly. It really makes you wonder what else might become possible as we go deeper into this quantum rabbit hole. New forces, new dimensions, new ways of looking at the universe.
The possibilities are literally endless. And that's what makes quantum physics so incredibly captivating. It's a journey into the unknown.
It really is.
Yeah.
And it reminds us that we've only just scratched the surface of what's out there. It's like we're on the verge of this whole new world, but like with any new frontier, there are going to be, well, potential downsides, right? Things we need to be careful about. The video didn't really go into that too much. What about the potential downsides of this whole quantum revolution?
Oh, absolutely. That's something we can't ignore. Like any powerful tool, quantum technology, it could be used for good or, well, not so good.
Yeah.
It's like they say, with great power comes great responsibility.
Totally.
Yeah.
So what are some of those potential downsides?
Well, for one thing, think about security. Right now, we rely on encryption to keep our data safe, everything from our online banking to, our personal messages.
Right.
But a quantum computer, if it's powerful enough, it could crack those codes like they're nothing. And then there's the whole issue of surveillance. Imagine sensors so sensitive, so powerful, that governments, corporations, anyone could use them to track our every move. It's kind of a scary thought.
Yeah, that's a bit unsettling, to be honest. It's a lot to consider. All this incredible potential, but also these potential risks.
Exactly. And that's why it's so important to have these conversations now, to think about the ethical guidelines, the rules, the regulations that we're going to need to make sure this technology is used responsibly.
So it's not just about the science, it's about making sure we're prepared for the impact it's going to have on society.
Exactly. Scientists, policymakers, the public, we all need to be part of this conversation. Because at the end of the day, we want to make sure that quantum technology, it benefits everyone, not just a select few.
Well said. This has been, wow, a truly eye-opening dive into quantum physics. It's challenged how we think about, well, everything. Reality, the universe, the possibilities.
It's been a pleasure exploring all of this with you. And the best part is, we're just getting started, really.
Yeah.
Who knows what amazing breakthroughs are still out there waiting to be discovered.
Exactly. So, to everyone listening, keep those questions coming. Never lose that curiosity, because who knows? Maybe one of you will be the one to unlock the next big secret of the quantum world. Thanks for joining us on this deep dive.